Okay, what type of function is shown? When you're looking at this, you need to look at the table and you need to see, does x and y have a common difference, common ratio, or second differences? Now, common difference is the easiest one to see. When you look at x here, well, really in all the tables, to go from the first x value to the second is plus 1, to the third plus 1, to the fourth plus 1. So each and every one of these has a common difference in x. Let's look at this one first. How do you get from 2 to 4 by either multiplication or addition or subtraction? Well, from 2 to 4 is plus 2. How about 4 to 6? Plus 2. And 6 to 8 plus 2. So we have a common difference in x of plus 1, common difference of y plus 2. Whenever you have a common difference in both x and y, that is a linear function. This thing will form a straight line. Now let's take a look at this. Again, we're going to check for addition and subtraction, see if we get the same thing, or multiplication. From 2 to 4 is plus 2, but 4 to 8 is not plus 2. 8 to 16 is not plus 2. So let's check multiplication. From 2 to 4 times 2, 4 to 8 times 2, so on there. So this in y shows a common ratio. Whenever you have a common difference in x and a common ratio in y, that is an exponential function. Last one here, a little bit hard to see, usually the one people miss. If I'm looking for a multiplication pattern here, 1 to 4, 4 to 9, 9 to 16, there's nothing common there that you're multiplying each time. So the first thing I want to check is how do you go from 1 to 4? Well, you can add 3. 4 to 9, you can add 5. And 9 to 16, you can add 7. Now if you look at this, what we call first differences, these are first differences, like the number 1 first. Do you notice anything about going from 3 to 5 and 5 to 7? Is there a common difference there? Yeah, plus 2 each time. These are called second differences. So if you have a common difference in x and second differences in y, for lack of a better term, a pattern within the pattern, although I don't like the word pattern, that's a quadratic function. So, there you go.